Okay, so lesson 10 is modeling sinusoidal functions. And so what we did in the last lesson is we were given the equation of the sinusoidal function. And in this lesson, what we have to do is we have to derive the equation of the sinusoidal function. So we have to come up with the parameters of A, B, C, and D using the graph. Okay? So just to do a review, the sinusoidal wave shown to the right has a maximum value of 10 and a maximum value of 50 and a minimum value of 10. Write the equation of the sinusoidal wave in the form of a sine graph. So we need to determine these values of A, B, C, and D. So what do I know about the value of A? What does A correspond to? A is the amplitude. Oops. There we go. So A is amplitude. How do I calculate the amplitude? So 50 minus 10 divided by 2 equals 20. Okay. I usually do the A and the D first, and then I look at B and C afterwards. So now if I look at D, D was that vertical displacement. How do I find the vertical displacement? So 50 plus 10 divided by 2 equals 30. And the reason why I figure out that vertical displacement is because it helps me find the center of the graph, which for a sine function is very important because that's where the sine function actually originates at. When I look at my sine x graph, it starts in the middle and then makes it movement up and down. Then I have C, which is my horizontal phase shift, and I have B, which is the relation to my period. So B is at 2 pi over the period. So to calculate the period, I either want to go from like a max point to a max point, or I need to find some value. So if I look here, I have the 0 mark. It's going down, then it goes all the way up to this point right here. How many units did I have to pass through to get to that point again? 32. So the period is 32. So then my B value becomes 2 pi over 32, which I can simplify to pi over 16. And then I have my horizontal phase shift. So again, if I remember with sine x, sine starts in the center and goes up. So if I look at where that actually happens in my graph, it's at this point. So I've actually shifted my entire graph to the right. How many units? 16. So this is 16 to the right. So then my equation would be h of t equals my A value, which is 20, sine pi over 16, bracket, t minus 16, brackets, plus 30. And if I took the graphing calculator out and I recreated the window settings, so my window settings are, my x's went from 0 to, let's see, each of these tick marks is 4, so 84 to 88. I went up by 4s. And then my y's went from 0 to 55, going up by 5s. And then my y equals, I would delete, clear this one. And then it would be 20 sine. I would open up another bracket, so so I could do my pi divided by 16 bracket, then open up another bracket to go x minus 16, and then I would close it twice, plus 30. Double check that you're in radian mode, press graph, and do the two screens tend to match? Yes. Okay? So now let's get into class example number 1. A nail is caught in the tread of a rotating tire at a point N in the following sketch. So N is the height from the ground to the nail. The tire has a diameter of 50 centimeters and it rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground. So it says, use the information given to write a scale for each axis. So do you want to start with the X or the Y? X, okay. What do I know? What is being measured along the X-axis? Pardon?
Is it seconds?
Seconds, it's the time. What do I know about my time?
After 4.5 seconds, it touches the x-axis.
So this would be 4.5, okay. What else do I know?
There's 10 revolutions per minute.
Okay. So how long does it take for one revolution? So if there's 10 in 1 minute, how long does it take to complete one cycle?
6 seconds.
How'd you get 6 seconds? 60 divided by 10. So 6 seconds means this is 0. This right here has to be at 6, where it meets up again. And then meets up again at 12. I know that it takes 6 seconds for a rotation, so if it took 4.5 seconds for the nail to hit the ground the first time, that's 10.5 seconds for it to hit the ground the second time. What's the distance between 4.5 and 6? 1.5. So if I make my scale the same, my scale is now 1.5.
Why is it 10.5 seconds?
Because it's 6 seconds for a rotation, for a revolution. So it takes 6 seconds for it to go from here back to here again. So 6 seconds plus the 4.5 that I'm already at. So if I start subtracting by 1.5, there's 3, 1.5, and 0. Between 6 and even if you wanted to look at 12, if I started making my marks, and if you notice with my marks, if I was to draw this midline in here through N, quite exact. So with that midline in my sine graph, I end up getting some points. Like I get the point in the middle, and then in the middle again. In the middle, I get all these midline points, and then I get all these max and mins. So there's a midline, there's a max, a midline, a min, a midline, and a max again. So I keep adding by 1.5, I get 7, 9, 10.5, 12, and this last point would be at 13.5. Okay. What do I know about my vertical axis? What is my vertical axis measuring? Height of the nail. So what do I know about the height of the nail? What's the tallest height the nail can hit?
50 centimeters.
And how do I know it's 50?
Because
Yeah, the tire has a diameter of 50 centimeters. If this is my tire, and I have a nail stuck in it, the highest point that it's going to reach is this 50 centimeters. So this midline, this halfway mark, is at what?
25.
25. So now if I was to use this information to determine the equation for the height of the nail as a function of the time, where h of t equals a sine b plus t, or bt plus d, I need to determine the values for a, b, and d. I don't need a c because there is no phase shift. So again, how do I calculate the value of a? Max minus min divided by 2. My max is 50. What's my min? So 50 minus 0 divided by 2 is 25. Does that make sense if I look at the picture? Does 25 for an amp seem right? Is that the measurement from the midline to the maximum? Okay. Do you want to do B or D first? D? So how do I calculate D?
Maximum plus minimum divided by 2.
So 50 plus 0 divided by 2 is?
Like that.
Does that seem like the appropriate midline? Yeah. Okay. So now I'm left with B. How do I calculate B? And what is the period?
6.
And so if I simplify 2 pi over 6, what do I get? So then my equation becomes h of t equals 25 sine pi over 3 t plus 25. And question C says, how far to the nearest tenth of a centimeter is the nail above the ground after 6.5 seconds? How would I determine that? Replace t by 6.5. So I'd like you to do that first and see what you get. Okay, so what do you get for an answer?
37.5 centimeters.
So the nail's 37.5 centimeters above the ground at 6.5 seconds. Good. Okay, the last question, Ferris wheel. The first Ferris wheel ever built was built by a bridge builder by the name of George W. Ferris in 1893. The diameter of the Ferris wheel was 76 meters. Take a moment to think of how big 76 meters would be, given that a door frame is about 2. Okay? The maximum height of the Ferris wheel was 80 meters, which meant it was how many meters above the ground? The bottom cart. 4 meters. The wheel had 36 carts on it, and each cart could hold 60 people. How many people could go on this, in theory? How many people could you put on this cart? Hmm?
72?
No, 36 carts.
2,160.
60 people on each of the 32 carts, 2,160 people. You could put half of Fairview on the Ferris wheel. Okay. The Ferris wheel was first introduced at the World's Fair in Chicago in 1893. The illustration is a copy of the photograph of the original wheel. The wheel rotated every 9 minutes. So it took 9 minutes for it to go through one rotation. It says, use the data in the table to sketch a sinusoidal function or sinusoidal graph which represents the height of the car in meters as a function of time in minutes. Assume that the car is at its lowest point at t equals 0 and draw one complete cycle. So if this is the cart that I'm looking at, is this one right here. times 0, what is the height of that cart? 4 meters. So that's where my starting point is going to be, is I want to graph this at approximately 4 meters. What is the maximum height the Ferris wheel is going to get? 80. So it's going to go up to this point here. How long does it take to get to 80?
Oh, wait,
Half the time. So at 4.5 minutes. And then at 9 minutes, it's going to be back down to its 4. And so I've taken care of these 3 points. Halfway in between 4.5 and 0 is 2.25 minutes, which means it's going to be halfway in between. So if the diameter is 76, the radius is 38. So then if I take my 38, add in the 4 meters I started at, that's how you get this 42 meters in here. So 2.25 would be at 42. And the same thing at 6.75. So in this diagram, we should have some lines, or we should have some points that are occupying the same plane. And then I join these points with a smooth curve, which is not what I have there. Start over. Close enough. Yeah, mine's probably not very drawn to scale, but this gives us at least an idea of what this should look like. Now what we're asked to do is we're asked to determine the graph of the equation in what form this time? Cos. And cos is going to impact which variable? Compared to, oh sorry, let me rephrase my question. Compared to a sine graph, which one of these will be the one that I have to watch for the most? C, the horizontal phase shift, because I'm dealing with cos. Okay? So, how do I calculate A? Actually, I'm going to give you guys a couple minutes. I want to see if you can do this equation on your own. So calculate A, B, C, and D. The only thing that when you're calculating your C value, where does cos usually start at? At the top. So when you're looking at your phase shift, you're going to shift it to the top part of the graph. So if I look at these values, again, A is referred to, or it's the amplitude. So that's max minus min. 80 minus 4 divided by 2, which is 36, which, or sorry, not 36, 38. Which actually corresponds to the diameter of the Ferris wheel. My D value is my vertical displacement. I add, and I get 42. So that's my midline. That would be this measurement right here that kind of cuts through the center. Then we have the B value, which is 2 pi over the period. And we know the period is 9 minutes. So I get 2 pi over 9. And then my horizontal phase shift, which is my C value. If I look up at my graph again, it's hitting this maximum point, which happens at 4.5 seconds. So my horizontal phase shift would be 4.5, not seconds, minutes, to the right. So my equation would be h of t equals 38 2. So then C says, how high to the nearest meter is the cart 5 minutes after the wheel starts rotating? How can I determine this answer?
You replace T with 5.
Okay, so replace T with 5 and tell me what you get.
It would be 77.7 meters. So if we divide to 7
So to the nearest meter, 78 meters. Okay? And then D says, how many seconds after the wheel starts rotating does the cart first reach 10 meters from the ground? How would you do that one? Graphing it is probably the way to go. So I would let the h of t equation be equal to y1. And then I would let y2 be equal to 10 and find the intersection. And what did you get for an intersection point, Evan?
0.8159. 11 minutes
So how do I convert that to seconds?
times 60.
And when I multiply that by 60, what do I get?
48.9.
So 48.955, which would be how many seconds?